Welcome to day one of our Algebra Summer Prep Class, and this is just going to be a brief description and a little bit of help as to what we did on day one for those who were not here, as well as maybe those who would like to review it again. We're going to start off with just solving a simple equation, a multi-step equation. We have one variable and it's on both sides of the equation. So we want to get it all to one side so that we can solve for x. We call these a linear equation because it has just one variable in the in the equation. If I look at this, I have 6x's, I have 7x's. I'm going to go ahead and get rid of the 6x's and bring it over here, just because that will make things a little easier for me because it stays positive then. And so I'm going to bring that over. 6x minus 6x cancels out, and I'm left with 7 equals 13 plus 7x's minus 6x's equals just 1x. And so as I continue to solve for the x's here, I'm going to get rid of the 13 because it's on the side of the x. I want to keep the x isolated. And I'm going to subtract 13 over here. Those will cancel and I'm left with x. 7 minus 13 is negative 6. And some of your teachers or yourself, you may want to flip that around to where x equals negative 6. We can always check ourselves, which is always a great thing to do. We say that x should equal negative 6 to make this a true statement, so I bring it back up in here. 6 times a negative 6 plus 7. 6 times a negative 6 is negative 36. Negative 36 plus 7 is negative 29. If I come over here, I have 13 plus 7 times a negative 6. 7 times a negative 6 is negative 42. 13 plus a negative 42 also equals a negative 29. So we have proven that our answer is correct. Again, most of this should be somewhat familiar to you. Should be a little bit of a review, hopefully, of things that you have covered in pre-algebra. Let's do one more, and then we're going to move on to something a little bit new. So let's say I have 3, and we have 1 minus 3x, and we have that equal to 2 times a negative 4x plus 7. Now obviously I have some parentheses here, which is going to bring up something else that you should probably remember called distributive property. I'm going to take my 3 and multiply it times both the numbers that are inside the parentheses. So 3 times 1 is 3, minus 3 times 3x, which is 9x, is equal to 2 times negative 4x, which is negative 8x. And then we have 2 times 7, which is plus 14. Now that looks a lot like what we just did. We want to get the variables on one side or the other, and the what we call the constant terms by themselves as well. This time I'm going to go ahead and get rid of the 9x. And it's a minus 9x, so in order to get rid of it, I need to add 9x to it. But if I do 9x here, I also have to do 9x over here. So those will cancel, and I'm left with 3 on this side of the equal sign. I'm left with negative 8x plus 9x, which just gives me x. And then I have a 14. Again, this should hopefully be familiar to you. If not, then just slow the video down and check it over. I'm going to subtract 14. I'm going to subtract 14 from both sides, and I'm left with x is equal to, in this case, a negative 11. Again, we can switch that around if we want into x equals negative 11. We can bring that back up in here. 3 times negative 11 is a negative 33. So 1 minus a negative, which really becomes positive. So 1 plus 33 is 34. 34 times 3 is 102. Over here we have negative 4 times negative 11, which gives us a negative times a negative is a positive 44. 44 plus 7 is 51. 51 times 2 is, guess what? 102. we are correct with our answer here, and so we have x is equal to -11. So again, hopefully this is a little bit of review. I'm going to send with you some work that you can continue to practice that, because those are going to help us in the very near future as we get into absolute value equations and inequalities and graphing those things. So with that, we want to start on a little bit today as well onto absolute value equations. And whenever we talk about the absolute value, what you should already have had in your brain before is that anything in the absolute value sign really represents its distance from 0 on a number line. So if I have the number 3 and I think of myself standing on a number line and I'm walking, how many steps would I have to take in order to get to the number 0? And if I'm on 3, that means I would have to take 3 steps to get to 0. So the answer to the absolute value of 3 is 3. The same thing happens, however, if I'm on -3. The absolute value of -3 is saying how many steps would I have to take in order to get from -3 to 0? Well, I can't really walk backwards and take away distance. I'm still traveling the same amount of distance. It just happens to be in a different direction. So the reality of it is, to get from -3 to 0 still takes me 3 steps. The shortened way to think of that is that anything in the absolute value signs become positive. And that's how a lot of you remember those things. When you think of absolute value, it's always going to be a positive answer. Okay? Well, now as we're heading into algebra, things are going to ramp that up a little bit, because we're not only going to have numbers, but we're also going to have some variables included in our absolute value sign. So we might have the variable, or the coefficient in the variable 3x is equal to 9. So now what do we want to do is we want to say, what value, or hint, 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 what values could x be, so that when I took the absolute value of it, it could be 9. So we obviously can look at that and we can say, well, 3 times 3 would equal 9. So I know that x could equal 3. But if we think about it, and we think about what an absolute value does to a number, we can also look at this and say, if 3 works, what if I plugged a -3 in for x? What is 3 times a -3? Well, 3 times a -3 is -9, and we know that -9 in an absolute value sign is also equal to +9. And so we know that x could actually equal 3, or it could equal -3. Does everybody understand that? Hopefully that makes some sense to you. So we look at this and we go, well, okay, but what happens when it gets a little bit tougher? How am I going to solve that, and how am I going to think through that in my brain? So let's write one that's a little bit longer, a little bit tougher for us, and let's think through what's another way we could get to those answers. So let's say I have -4x, -4 plus 5x in the absolute value signs, and we're going to set that equal to 16. Now we kind of need another strategy in order to get to the answer, because I can't necessarily, maybe you can, but I can't necessarily look at that and go, I know both of the answers. No. That's going to take me a little bit more thought than, maybe my brain wants to do on a morning or something like that. So here's another strategy that we can look at with this. If I'm looking at what's inside this absolute value sign, what I'm really looking at is whatever's in here, when it's solved, must equal 16. But what I also understand is that whatever is in here could also equal -16, because once I take the absolute value of -16, won't it also equal positive 16. So what I can do is I can set up myself two equations. Because when I'm dealing with absolute value and I have a variable inside there, I'm really going to get two answers. So the first one, I'm just going to set up the equation that it looks like, and I'm going to drop the absolute value signs, and there's equation number 1. Now what I also want to do then is, because I know this can equal 16, I also know that it can equal negative 16 as well. And so now I have two equations. If I go through, solve it just like we were practicing, that's why we were practicing in the beginning, I end up with 5x is equal to 16 plus 4, which is 20. I divide by 5, I divide by 5, and x is equal to 4. If I come over here and I want to solve this one, I'm going to add 4, I'm going to add 4, and I am left with 5x is equal to negative 16 plus 4, which is a negative 12. Now I want to divide by 5 in order to isolate the x. Divide by 5 in order to isolate the x over there. 5 divided by 5 is just 1. 1 times x is x. Then I'm left with negative 12 over 5. So I know my numbers that would work are both 4 and negative 12/5. And you may say to yourself, well, Mr. Gull, I don't know how that's going to work, because that one's kind of weird looking. But let's try it out. Let's see what it works. Let's first of all do the easy one. With 4, 5 times 4 is 20. 20 plus a negative 4 is 16. The absolute value of 16 is 16. So we're good on that one. We're good on that one. So now let's get to the one that's a little bit more tricky. We have negative 12/5. So let's rewrite that as negative 4 plus 5, which is really 5 over 1, right? Times negative 12 over 5. Well, if I can know how to cross cancel, I can get rid of those, or I can just multiply across. 5 times negative 12 is negative 60. Negative 60 divided by 5 is negative 12. What is negative 12 minus 4? Negative 12 minus 4 is negative 16. Now watch what happens. Because it's still in the absolute value sign, what is the absolute value of negative 16? Well, it is equal to 16. Thus, we've proven that both of these could be possible answers. Hopefully that makes some sense to you as well. And again, if it gets stuck on something, go ahead and slow it down. Go through it again and again. Let's do one more, a little bit, maybe a little bit more challenging, a little bit more tricky. And we'll go as our final example. This one's, again, taking the same things we know from solving equations and applying them to absolute value equations. Let's look at this one. We have 6 times the absolute value of 1 minus 5x minus 9, and that equals 57. Now, as we look at this one, our whole goal in solving an absolute value equation is to get the absolute value stuff all on one side of the equal sign to where it's all by itself. Okay, so that's what we want to do. And as we look at this, it's still algebra. And when we do algebra and we're solving equations in algebra, hopefully you understand this from years past, that we're really kind of undoing a problem so that all we're left with is the x by itself so that we can work through that. Well, if we undo a problem, we almost follow the opposite of the order of operations. And so if I'm looking at this, I see there's a multiplication, and I also see there's a subtraction. In solving a problem with order of operations, we would obviously multiply before we subtract. But since we are undoing things, we're working backwards, we're actually going to do the subtraction. And the opposite of subtraction is addition. So we're going to add 9 to both sides. So I'm left with 6 times the absolute value, 1 minus 5x. And now my 9 is over here, and so I end up with 57 plus 9, which is 66. Then I have a multiplication. Again, I'm trying to get the absolute value where it's all by itself. So I'm going to divide by 6 because this is really a multiplication. There's no sign in between the absolute value sign and the 6, so it's really just a multiplication. So in order to solve a multiplication or rework or undo a multiplication problem, I divide. And if I divide over here, I must divide over here as well. So now I have 6 divided by 6, which is just 1. 1 times all of this is still just the absolute value of 1 minus 5x. Over here, I have 66 divided by 6, which is 11. Now this should look familiar because now we can solve with 2 equations. My first equation is going to look just like what we have set up here, and we have 1 minus 5x is equal to 11. Erase that a little bit, just give us a little bit more room. And over here, I've got 1 minus 5x is equal to negative 11. Because we know that whatever is in here has to equal 11. Well, we also know that if it equals negative 11 in here, the absolute value signs will change it to a positive 11, so it could equal negative 11 in here as well. We're going to subtract 1, I end up with negative 5x is equal to 10. Divide by negative 5, divide by negative 5, and we have x is equal to negative 2. Okay? Over here, do the same thing. We're going to subtract 1. I know it's kind of getting crowded down there. Hopefully I won't lose you. Negative 1, negative 1. These will cancel each other out. I end up with negative 5x is equal to now a negative 12. It's going to look familiar, isn't it? We're going to end up with very similar answers to what we had last time. We're going to put a little arrow here and put our answer. We divide both by negative 5, divide by negative 5, and I end up with x is equal to 12 over 5. So we have 2 answers. Let's take them, plug them back in. Obviously our easier one, negative 2. 5 times negative 2 is negative 10. 1 minus a negative 10 is really 1 plus 10. So that gives us 11. What is 11 times 6? 11 times 6 is 66. Minus 9 equals 57. And guess what? 66 minus 9 is 57. So we know that negative 2 works. We know that negative 2 works. Now let's try 12/5. Positive 12/5. So I'm going to take 1 minus 5 times 12/5. And we know from our last problem that we can cross cancel the 5s, or we can multiply across and divide. But either way, we're going to end up with 12. What is 1 minus 12? 1 minus 12 is negative 11. The absolute value of negative 11 is positive 11. So 11 times 6 is 66. Minus 9 equals 57. And there we are again. So we can prove that both negative 2 and 12 over 5 work as solutions to our absolute value equations. Take a few minutes, go through these over and over again until it seems to sink in a little bit with you, and next time you're in, we will continue to work through all of this and hopefully make it a little bit more solid in your mind. But that's what we covered in day one of Algebra 1 prep class for the summer.